morning. This is your stats sensei, Mr. Spensei, and this is a warm up of the paired t-test, and this is back to grandparents. The Abuelas continued. Um, a sociologist was investigating the ages of grandparents of high school students. The sociologist collected data on the current ages and years of the students' maternal grandparents by taking a random sample of 10 high school students out of 1,163. The data is shown in the table above. The results for the hypothesis test are given below. Also, I should note that basically they wanted to know whether or not the grandmother was younger than the grandfather. And we previously put this information in the calculator, but I'll real quickly went to stat edit there. Oops, stat edit, and there it is. And if I go to the top of L3, blue button 1 minus blue button 2, I get the differences. So basically 75 minus 74, 70 minus 75, et cetera, et cetera. And it did it itself. Stat calc, one var stats, blue button 3, and I find out on average a negative 1.3, standard deviation of a 5.755 of the sample, and the sample size, of course, was 10. So that's the information we had. Uh, Mu D is because our null hypothesis is that there's no difference. And because we said the grandmother was younger than the grandfather, we have mu D less than 0. And here's the way I'm going to explain that. Because this is the grandmother and this is the grandfather. Doesn't matter what age you pick, but let's just say the grandmother we picked was 70. We think the grandfather's older. We chose 75. Well, 70 is less than 75. So that tells me if I go in this order, I'm going to get some value less than 0. It's a t-test for the difference in means. We just plugged into our formula, and that was all the values. And what we had not done is we hadn't defined the parameter before, so we're going to do that. Let mu d equal the true population mean of the differences in grandparents' age, grandmother minus grandfather, or you could just put ages, grandmother minus grandfather. Super important that you have the order that you subtract in, because while you'll get everything will be the same, but the values of your test statistics will go from negative to positive or vice versa, depending on the order you choose. The conditions, well, we had in our previous, it said there was a random sample of 10, that's up here at the top, and that was given. And we also know that we had a population of 1,163. So 10 times 10 is 100. That's less than 1,163 and is less than 10% of the population. So we're fine there. Then we went to our box plot, second stat plot. Press enter. Make sure it's on. Drop down and select the box plot showing the outliers. Blue button and number 3. Once we have that in, we can press zoom 9. And we can look at it and we go, okay, there's a box plot and it's reasonably symmetric with no outliers. The distribution appears normal enough. That's our explanation. Make sure you label it as age differences. I don't label things very well, so I use a scale. I mean, I don't use the scale. I actually label the individuals. And we have a minimum of negative 10. Q1 is negative 5. The median is negative 1. Q3 is 4. And the max is Q8. Alternatively, you could have gone stat calc, one var stats. And there it is, minimum of negative 10, Q1 negative 5, median Q3, Q4, and a Q3, and then the maximum. All right, when we ran the test, we went stat test, t-test. We claimed that there was no difference, so that's a 0. Oh, and we had data, excuse me. And our blue button 3 is where the differences are stored. We have less than chosen for our alternative. So there's our mean of 0, less than, change this color or try to. There we go. And I ended up getting a t statistic of negative 0.7143. All right, with a p-value of 0.2465. So 0.2465 compared to my alpha of 0.05 that was given in the previous problem. We say with that, whenever the p-value is larger than alpha, we fail to reject. So our conclusion, our p-value is 0.2465, which is greater than our alpha of 0.05. We fail to reject the null. There is not sufficient evidence. In other words, we don't have enough evidence to suggest the true population mean of the differences in ages, grandmother minus grandfather, is less than 0. Please remember, this part right here is just a restatement of the alternative, is a statement of the parameter. Let mu d equal the true population. There it is. Same thing here. And this part right here, less than 0, is just putting the alternative hypothesis in words. Less than 0. So less than 0. So that's where that came from. Hope that helps. The next video, we will have an exit ticket on the same type of problem. Appreciate you watching. Look forward to seeing you on the next one. Thank you.